Hello and welcome. In this lesson, we are going to discuss the probability distributions in R. Let's start with the first probability distribution, namely binomial distribution. Recall that a binomial distribution or a random variable with binomial distribution has three parameters, namely x, n, and p, where x is the number of ones or number of successes and the number of trials, and p is the probability of getting one or a success. In R, we use the function dbinom with entries x, n, and p to calculate the probability of x equal to small x for a binomial random variable x. One can also calculate the probability of a vector of ones or successes in one go. To that end, obviously, we first need to create that vector as x, which is a vector of the number of successes or ones from 0 to n, and then run the d-binomial on this vector x, which now contains more than one value. One can then plot the probability vector against the vector of number of ones or x. The binomial with this one getting one success out of two trials with the probability of success being 0.5 gives us the probability of getting one success in two tries where the probability of getting success is 0.5 is 0.5, and that's very obvious. In the next example, 30% of households in a village depend entirely on agriculture. 12 households are randomly chosen. What is the chance that X of these households depend on agriculture? So the probability of success is 0.3. N is 12, so that is 12 households being chosen randomly. We can calculate the probability of 0 households, 1 up to 12 households from the 12 households that we have chosen that depend on agriculture. So we create a vector from 0 to 12 and then apply our d-binomial on this vector and calculate the probability of all from 0 to 12 in one sitting. And then we can plot the probability against the vector x to check the behavior of the probabilities. So this graph shows the probability of getting 0 household, 1 household, 2 households, and so on up to 12 households. As you can see in the graph, the probability of getting 3 households up to 4 households is the highest, and as we move to higher number of households, the probability of getting these number of households depending on agriculture simply decreases. The reason why this probability is highest around 3 and 4 is this 30%. The second distribution is the Poisson distribution. Recall that Poisson distribution has namely one parameter lambda, where lambda is the average of occurrences per unit of time or per unit of space. In R, we use the function dpoi dPoisson k and lambda to calculate the probability of x equals to k for a Poisson random variable x. One can also calculate the probability of vector of occurrences in one sitting. To that end, clearly we need to create that vector first from 0 to n, for n being a natural number bigger than 0, and then apply the dPoisson on this vector and then plot the probabilities. For example, if we have an online shop, on average the shop has 4 visits every hour. What is the probability that we get 0, 1, or 4 visits in the next hour? If you want to calculate the probability of 0 visits, you calculate dPoisson 0 and 4, which is 0.01 or nearly 2%, and 1 visit would be the probability would be 7%. However, if you want to estimate the chance of 0 to 12 visits in the next hour, you create a vector from 0 to 12 and then calculate the probability for all of these number of visits using this vector and applying the dPoisson function on this vector with average being 4, and then plot the probability. As you can see here, the probability is again maximum around 4 because that is the average. Around the average, the probability is maximum. And as we increase the number of visits to 6 and higher numbers, the probability is going down. The third probability distribution that we have studied is the geometric distribution, which has one parameter p, where x is the number of successive failures before one gets the first success. And R, we use the function dgeometric, dgeom, x and p to calculate the probability of x equals to x for a geometric random variable x. One can also calculate the probability of vector of successive failures from 0 to any number. For that, we need to create the vector and then run the dgeom function on x, which is now a vector of successive failures starting from 0 up to n. Then one can plot these probabilities. The chance of a stock trader to make a profit on certain days, 35%. What is the chance that the trader makes a profit on the first, second, or fifth day? So this is a geometric distribution. We apply our dgeom on 0 on the first day. So here, remember, this is a success on the first day. So 0 means there is no failure. So that's 35%. 1 means there is one failure and there is success. That means there is a success only on the second day. So the probability of that would be 0.2275. And the probability of getting a success or making a profit on third day after failing to do so in the first 2 days is 0.35, and that would be nearly 1.5 or 15%. If you want to calculate this probability for a vector of numbers, let's say from 0 to 14, we can create a vector from 0 to 14 and calculate the probability for this vector and plot it. As you can see, the probability is highest on the first day and it just decreases as we move on to other days. That means the probability that we have to wait 2 days before we get a success is nearly 15%, but the probability that we have to wait 14 days before we get the first success is really minimal and nearly zero. The uniform distribution. A uniform distribution has two parameters, namely minimum and maximum. The probability that x is equal to x is 1 over maximum minus minimum, for x being in 1, 2, 3 up to n. X is the number that we want to draw out of the vector. In R, we use the function duniform x min max to calculate the probability that we get x out of the vector x. One can also calculate the probability of vector of successive numbers in one go. For example, if we have a vector which takes values from 1 to n, then we calculate the probability that we get any of these numbers by applying the duniform function on the vector x, and then obviously we can plot it. How much is the probability that we get 8, with the minimum being 0 and maximum being 10? So that would be a 1 over 10. We can calculate the probability of the whole vector from 0 to 10, compute the probability of all of them using the uniform, and then plot it. Expectedly, you see the probabilities being across the same straight line because the probability of getting each of these numbers is 0.1 and they are the same. And that's why this probability distribution is called uniform distribution.